March 7th, 1945. Nakajima Aircraft Company Testing Facility, Ota, Gunma Prefecture. Chief Engineer Kikuhara Shindo knelt beside the twisted wreckage of what had been a General Electric remote-controlled gun turret, his hands trembling as they traced the barrel of a 20mm cannon. Around him, a dozen engineers maintained respectful silence, waiting for their superior to speak. The mathematics were impossible, the engineering was impossible. Yet here lay the physical proof, recovered 3 days earlier from a B-29 that had crashed near Nagoya after a night firebombing raid. For 18 months, Japanese intelligence reports had described these weapons. Interrogated American prisoners had confirmed their existence. Photographs from crashed bombers had shown their outlines, but Japanese military leadership had dismissed the claims as propaganda, as American psychological warfare designed to demoralize defenders. 20mm cannon mounted in aircraft, turrets, and fired by remote control violated every principle Japanese engineers understood about aerial gunnery, weight distribution, and structural integrity. Now Shindo held irrefutable evidence in his oil-stained hands. The barrel alone weighed more than an entire Type 92 machine gun. The ammunition drums, designed to feed explosive shells at rates exceeding 400 rounds per minute, represented manufacturing precision Japanese factories could not achieve. The fire control computer, partially destroyed in the crash but still recognizable, contained miniaturized electronics that seemed decades beyond current Japanese capability. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What Shindo could not yet comprehend was that this single turret represented merely one component of a weapons system so sophisticated, so thoroughly integrated, and produced in such overwhelming quantities that Japan's entire aviation industry could not have replicated it, even if given complete blueprints and unlimited time. The B-29 Superfortress carried 4 of these turrets, plus a tail position mounting twin 20mm cannon. Each bomber was a flying fortress in the most literal sense, bristling with firepower that Japanese interceptors approached at mortal peril. The story of how Japan's military establishment refused to believe in these weapons, then struggled to comprehend them, and finally faced their devastating reality, reveals the profound technological and industrial chasm that doomed Japanese resistance long before the atomic bombs fell on Hiroshima and Nagasaki. The path to this moment of terrible recognition had begun nearly 4 years earlier, in the optimistic months following Pearl Harbor, when Japanese planners believed their swift conquests had secured an impregnable defensive perimeter. Throughout 1942 and into 1943, Japanese intelligence services compiled fragmentary reports about American bomber development. Agents in neutral countries forwarded technical journals. Communications intercepts revealed project code names. Escaped prisoners from the Philippines and Java brought rumors of a massive new bomber under development in American factories. These early intelligence reports described an aircraft of unprecedented size and capability. Maximum takeoff weight exceeding 130,000 pounds, service ceiling above 30,000 feet, combat radius allowing strikes on Japan from bases as distant as the Mariana Islands or India. Most alarming were references to defensive armament far heavier than any bomber had previously carried. Japanese military intelligence officers at Imperial General Headquarters reviewed these reports with professional skepticism. American bomber development had followed predictable patterns. The B-17 Flying Fortress, encountered in the Philippines, a campaign, mounted 1350 caliber machine guns in manually operated turrets. The defensive armament was formidable, but within comprehensible parameters. Machine guns, even heavy 50 caliber weapons, could be evaded through skilled fighter tactics, overwhelmed through massed attacks, or endured by heavily armored interceptors. But the new reports described something different. Remote-controlled turrets firing 20mm cannon, multiple gun positions coordinated by central fire control systems, computing sights that automatically calculated lead angles, deflection, and range. To Japanese engineers trained in conventional aviation design, these claims seemed fantastic. The weight of such systems would be prohibitive. The structural stresses would exceed aircraft design limits. The complexity would create maintenance nightmares impossible to sustain in operational service. Colonel Takeo Yasuda, Chief of the Army Air Force's Technical Intelligence Section, wrote in a confidential assessment dated November 1943 that American claims regarding the B-29's armament likely represented deliberate misinformation. His reasoning reflected conventional wisdom among Japanese aviation experts. A 20mm cannon weighed approximately 100 pounds, roughly 4 times the weight of a 50 caliber machine gun. Ammunition for these weapons was correspondingly heavier. The recoil forces during sustained fire would stress airframe structures beyond acceptable limits unless massive reinforcement was added, further increasing weight. Yasuda calculated that mounting 20mm cannon in multiple remote-controlled turrets would add at least 4,000 pounds to an aircraft's empty weight. This weight penalty would severely compromise range, ceiling, and payload capacity. American engineers, he concluded, would never accept such trade-offs. The reports must be exaggerated or fabricated. Japanese fighter pilots would face standard machine gun armament, dangerous but manageable with proper tactics. This assessment contained a fundamental error that would prove catastrophic. Japanese engineers projected their own industrial limitations onto American design capabilities. Japanese aircraft manufacturers, constrained by limited aluminum supplies, primitive metallurgy, and inadequate machine tools, built aircraft with minimal structural margins. Weight was the enemy. Every kilogram added meant performance compromised. Japanese designers shaved weight wherever possible, often sacrificing pilot protection, fuel tank armor, and redundant systems to achieve desired speed and maneuverability. American designers operated under entirely different constraints. Abundant aluminum supplies, advanced metallurgical processes, and sophisticated manufacturing equipment allowed American factories to build aircraft with generous structural margins. Weight could be added where it provided operational advantage. Pilot protection, self-sealing fuel tanks, redundant control systems, and heavy defensive armament were standard features, not luxuries to be eliminated for marginal performance gains. The first B-29 raids against Japan, launched from bases in China beginning June 15, 1944, provided Japanese forces their initial direct encounter with American strategic bombers. 75 superfortresses departed Chengdu, though only 47 reached the primary target at Yawata on Kyushu. Japanese radar operators detected the approaching formations shortly after dusk. Air raid sirens wailed across the city. Pilots of the Imperial Army Air Force's 4th Sentai scrambled to their Kawasaki Ki-45 Toryu twin-engine fighters, climbing aggressively toward bombers flying at altitudes between 8,000 and 21,000 feet. Even at these relatively modest heights, dictated by fuel constraints on the long mission from China, Japanese interceptors struggled against the B-29's speed and defensive firepower. Warrant Officer Sadamitsu Kimura managed to close on one superfortress, the aircraft designated canned heat with 12 crew aboard. His attack succeeded after expending nearly all his ammunition, sending the B-29 down in flames with no survivors. But Kimura's victory came at terrible cost. His engines overheated dangerously at altitude, several bullet strikes from defensive gunners had punctured his fuel tanks, and he barely returned to base with his aircraft trailing smoke. Around him, other Japanese pilots fired desperately at silver bombers, but most attacks failed to inflict significant damage. What shocked veteran fighter leaders was not simply that B-29 seconds were difficult to shoot down. That was expected with any well-built heavy bomber. What stunned them was the precision and effectiveness of American defensive fire. Japanese pilots reported that B-29 gunners opened fire at ranges exceeding 1,000 meters, far beyond the effective range of handheld machine guns. Tracer patterns converged with uncanny accuracy, as if multiple gun positions tracked attackers simultaneously. Most disturbing were reports from pilots who survived close encounters. Several claimed to have seen explosive shells detonating near their aircraft, the distinctive flash and smoke pattern of 20mm high-explosive rounds. These reports were dismissed by intelligence officers as stress-induced misidentification. 50 caliber incendiary rounds could produce similar visual effects. The pilots, facing combat at extreme altitude with oxygen equipment barely functioning, had simply misinterpreted what they observed. Captain Teruhiko Kobayashi of the Imperial Army Air Force's 244th Sentai, one of Japan's most experienced fighter commanders with victories dating to the China campaign, filed detailed after-action reports following early B-29 encounters. His unit had engaged superfortresses on 3 occasions during July and August 1944. Kobayashi noted that American gunners demonstrated unusual consistency in their shooting. Instead of wild spray and pray tactics common with manual gunners, B-29 defensive fire came in controlled bursts that followed attacking fighters with mechanical precision. Kobayashi speculated that Americans might have developed improved gun sights or training methods. He did not yet realize he was facing something far more sophisticated than enhanced training. The B-29's central fire control system, developed by General Electric, represented a quantum leap in defensive gunnery technology. Each turret gunner sat at a computing gunsight station equipped with optics, gyroscopes, and analog computers. When a gunner tracked a target through his sight, the system automatically calculated range using optical range finding, determined target bearing and rate of change, computed required lead angle accounting for bomber speed, altitude, and target maneuvers, and adjusted turret, a position to place rounds on target. Multiple gunners could simultaneously track the same target, with the fire control system coordinating their fire to concentrate rounds from several turrets onto a single attacker. The system even compensated for parallax, the geometric distortion that occurred because gunners sat offset from the actual gun positions. This technological sophistication was unprecedented in aircraft defensive systems. No other nation had developed anything comparable. Japanese intelligence officers, reviewing pilot reports from China-based B-29 raids, remained skeptical about claims regarding American cannon armament. The evidence was indirect and contradictory. Some pilots reported explosive shells. Others described standard machine gun fire. Examination of crashed Japanese fighters showed damage consistent with 50 caliber rounds. No 20mm cannon shells had been recovered from crash sites or extracted from damaged aircraft returning to base. The confusion was understandable. Early B-29 production models used different defensive armament configurations as Boeing and the Army Air Forces refined the design. Some aircraft mounted only 50 caliber machine guns in all positions. Others mixed 50 caliber machine guns in some turrets with 20mm cannon in the tail position. The definitive configuration, with 4 turrets mounting paired 50 caliber machine guns and a tail position with one 20mm cannon, did not become standard until later production blocks. Additionally, the extreme altitudes at which combat occurred, often above 20,000 feet, made damage assessment difficult. Pilots diving away from bomber formations after attacks, their oxygen equipment malfunctioning and vision dimmed by windscreen frost, could not reliably identify the caliber of rounds that had struck their aircraft. Maintenance crews examining damaged fighters lacked forensic capabilities to distinguish between large caliber machine gun hits and small caliber cannon strikes. The situation changed dramatically after the Mariana Islands fell to American forces in summer 1944. Saipan, Tinian, and Guam provided airfield sites only 1,500 miles from Tokyo, well within B-29 combat radius. Unlike the distant bases in China, which required bombers to fly over Japanese-held territory both coming and going, the Mariana bases allowed direct routes over open ocean until final approach to Japanese targets. The first B-29 raid from the Marianas struck Tokyo on November 24, 1944. Lieutenant Colonel Robert K. Morgan led 111 superfortresses of the 73rd Bomb Wing toward the Musashino aircraft engine plant. The formation encountered heavy fighter opposition as Japanese air defense forces, now alerted to the new threat, concentrated interceptors around the capital. The battle that developed over Tokyo that November morning provided Japanese pilots their most intense exposure yet to B-29 defensive firepower. Unlike earlier raids from China, which had occurred at dusk or night, this was a daylight precision bombing mission. Visibility was excellent. Combat occurred at altitudes between 25 and 30,000 feet. Japanese pilots had clear views of the bombers they attacked and the defensive fire that met them. Sergeant Pilot Yoshio Fukui, flying a Kawanishi N-1K Shiden fighter with the 302nd Air Group, described the engagement in his diary. American bombers flew in tight formation, their silver fuselages gleaming in morning sun. Fukui's squadron attacked from above and ahead, diving through the formation to maximize closure speed while minimizing exposure time. As Fukui closed to firing range, approximately 600 meters, he saw muzzle flashes from multiple turrets on his target bomber. Tracer rounds, bright even in daylight, arced toward his fighter. He pressed his attack, firing a 2-second burst from his 4.20mm cannon before braking hard right and diving away. In that brief moment, Fukui experienced something that made his blood run cold. Explosions erupted along his fighter's left wing, not the impact of solid projectiles, but actual detonations, small airbursts that shredded his wing's fabric covering and punched holes through aluminum structure. His first thought was anti-aircraft fire, but they were too high for flak to reach effectively. The explosions had come from the bomber's defensive guns. Fukui managed to return to base with his damaged fighter, landing with partial aileron control gone. Ground crew examining the damage counted 17 holes in the left wing, most with characteristics unlike .50 caliber machine gun strikes. The metal around several holes showed blast deformation, consistent with explosive shells. Similar reports flooded in from other pilots who had survived the mission. More than 20 Japanese fighters had been shot down or damaged severely, enough to crash land. Pilots described explosions near their aircraft during gun runs, fragments striking fuselages and wings, and in several cases, catastrophic detonations that destroyed fighters in mid-air before pilots could react. That evening, intelligence officers at 5th Air Force Headquarters in Tokyo conducted urgent assessments of the day's combat. The evidence was now undeniable. American bombers were firing explosive ammunition from their defensive positions. The question was whether these were merely explosive incendiary rounds fired from .50 caliber machine guns or actual 20mm cannon shells. The implications were significant. Explosive .50 caliber rounds, while dangerous, could still be countered through modified attack tactics. But if B-29 seconds truly mounted 20mm cannon in multiple turrets, Japanese fighters faced threats that conventional interception tactics could not overcome. Colonel Yasuda, whose earlier assessment had dismissed cannon armament as implausible, now faced contradictory evidence from multiple sources. He ordered a comprehensive review of all available intelligence regarding B-29 defensive systems. Technical analysts examined photographs of crashed B-29 seconds from China. Enhanced imagery revealed details of the tail gun position, showing a distinctive large-caliber weapon that appeared significantly heavier than standard machine gun installations. Interrogation reports from captured American aircrews were reviewed more carefully. Several B-29 gunners, when questioned about their aircraft's armament, had mentioned 20mm cannon in the tail position. These statements had been previously dismissed as attempts to inflate American capabilities for propaganda effect. Now they were reassessed as potentially accurate tactical intelligence. Most compelling was physical evidence recovered from crash sites. On August 20th, 1944, a B-29 from the 58th Bomb Wing had crashed near Anshan, Manchuria. After sustaining heavy damage during a raid on the Showa steelworks, Japanese army units secured the wreckage before Chinese guerrillas could interfere. Technical intelligence teams carefully documented the debris, photographing components before removal for detailed analysis. Among the wreckage, investigators found portions of the tailgun turret. The weapon mounting was unmistakably designed for a 20mm cannon. Feed mechanisms, partially destroyed in the crash and subsequent fire, showed characteristics consistent with large-caliber automatic weapons. Most definitive was the recovery of several intact 20mm shells from ammunition drums that had survived the crash relatively undamaged. These shells were immediately transported to Tokyo for examination. Ordnance specialists at the Army Technical Research Institute confirmed they were genuine 20mm high-explosive rounds, specifically ANM-2 ammunition manufactured for the Hispano-Suiza cannon. The rounds incorporated impact fuses and high-explosive bursting charges designed to detonate on contact with aircraft structures. Lieutenant Fumio Niwa, the engineering officer who would later examine turbocharger components from crashed B-29's, was assigned to analyze the recovered cannon ammunition. His report, filed in September 1944, provided the first comprehensive Japanese assessment of American 20mm defensive armament. Niwa noted that each shell weighed approximately twice as much as a .50 caliber round, but delivered roughly 5 times the destructive effect. The high-explosive bursting charge fragmented upon detonation, creating a cone of shrapnel lethal to aircraft structures and particularly devastating against unarmored fighters. What disturbed Niwa most was the manufacturing quality. American ordnance factories produced these shells to exacting tolerances. Fuses were reliable. Explosive charges were consistent. Quality, control ensured that virtually every round functioned as designed. Japanese 20mm ammunition, by contrast, suffered chronic reliability problems. Fuses frequently failed to detonate. Explosive charges varied in power. Approximately 20% of Japanese cannon shells were duds that failed to explode upon impact. Niwa calculated that an American B-29 tail gunner firing a 20mm cannon with high explosive ammunition possessed firepower equivalent to approximately 3 Japanese fighters firing simultaneously. The psychological effect on Japanese pilots would be severe. Attacking a bomber that could return fire with explosive cannon shells would require courage bordering on fatalism. Despite this mounting evidence, many senior Japanese officers remained reluctant to fully accept the implications. Admiral Soemu Toyoda, commander of the combined fleet, privately expressed doubts that Americans would waste resources mounting heavy cannon on bombers when machine guns had proven adequate for defense. Toyoda's skepticism reflected a broader pattern among Japanese military leadership. They had been trained to believe in Japanese technological superiority, particularly in aviation. The idea that Americans had developed defensive systems Japan could not match challenged deeply held assumptions about national prowess. This cognitive dissonance intensified as B-29 raids from the Marianas became daily occurrences throughout December 1944 and into January 1945. Japanese fighter units attacking these formations suffered unsustainable casualties. The 302nd Air Group, defending Tokyo and surrounding areas, lost 47 fighters in November alone. Only 16 were attributed to combat with American escort fighters. The remainder were shot down by bomber defensive fire or crashed due to battle damage sustained during attacks on B-29 formations. Pilots who survived multiple missions against B-29's developed profound respect for American defensive firepower. Captain Yasuhiko Kuroe, a veteran with 9 confirmed victories against Allied aircraft in New Guinea and the Philippines, wrote to his family in December 1944, describing the psychological strain of attacking superfortresses. American bombers, he explained, were not like the twin-engine bombers Japan had faced earlier in the war. Those aircraft, while dangerous, could be approached and destroyed through standard fighter tactics. B-29's were different. They flew at altitudes where Japanese fighters barely functioned, their engines gasping for oxygen in thin air. They flew in tight formations, concentrating defensive fire from multiple aircraft, and they fired explosive ammunition that destroyed fighters with single hits. Kuroe described watching a wingman's fighter disintegrate in mid-air when a 20mm shell detonated in the cockpit area. The pilot, a close friend, had no chance to bail out. The cumulative psychological impact on Japanese fighter pilots was devastating. They had been trained to believe that superior morale and fighting spirit, the concept of Yamato Damashi, could overcome material disadvantages, but no amount of spirit could protect unarmored fighters from explosive cannon shells. No degree of courage could help pilots intercept bombers flying at altitudes where Japanese aircraft barely maintained level flight. By January 1945, Japanese intelligence had compiled comprehensive data on B-29 defensive armament based on crash site examinations, captured documents, prisoner interrogations, and combat reports. The assessment concluded that late production B-29 seconds mounted the following defensive weapons: 4 remote-controlled turrets, 2 dorsal and 2 ventral, each equipped with twin 50-caliber machine guns, 1 tail position containing 1 20mm cannon and twin 50-caliber machine guns. Total defensive armament consisted of 10 50-caliber machine guns and 1 20mm cannon, all coordinated through a central fire control system. This configuration represented the most heavily defended bomber ever deployed operationally. Japanese intelligence officers calculated that a single B-29 possessed greater defensive firepower than an entire formation of German He-111 or Ju-88 bombers, which Japanese attachés in Germany had reported as formidable opponents for RAF fighters. The question facing Japanese air defense planners was how to counter this overwhelming defensive advantage. Several tactical approaches were attempted, each proving inadequate against the integrated weapons system Boeing and General Electric had created. Some units tried high-speed slashing attacks from above, diving through bomber formations too quickly for gunners to track effectively. This tactic occasionally succeeded but required precise timing and often resulted in overshoots, where pilots passed through the formation without achieving adequate firing time. The few seconds available for shooting rarely allowed pilots to inflict fatal damage on the robustly constructed B-29 seconds. Other units attempted coordinated attacks from multiple directions simultaneously, hoping to overwhelm the fire control system by presenting more targets than gunners could engage. This tactic proved suicidal. The central fire control system could quickly shift between targets, and multiple gunners could engage different attackers simultaneously. Japanese pilots found themselves flying through intersecting streams of fire from several bombers, with explosive shells bursting around their aircraft, regardless of which direction they approached. Ramming attacks became increasingly common as conventional tactics failed. Pilots deliberately collided with B-29 seconds, aiming for wings, engines, or tail sections, then attempted to bail out before impact. Few survived, but desperate commanders ordered these suicide missions with increasing frequency, hoping that trading one fighter for one bomber might represent an acceptable exchange ratio. The mathematics of this calculus were brutal. Japan's aviation industry in early 1945 produced approximately 150 fighters monthly. America's factories delivered more than 3,000 B-29 seconds alone during the same period, not counting the 8,000 additional fighters and thousands of other aircraft rolling off assembly lines. Even if every ramming attack succeeded, which they rarely did, Japan could not sustain attrition rates that high. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The night of March 9th to 10th, 1945, marked a tactical shift in the American bombing campaign that would have profound implications for both the effectiveness of B-29 operations and Japanese defensive responses. General Curtis LeMay, commanding 21st Bomber Command, ordered a radical departure from standard doctrine. Instead of precision bombing from high altitude during daylight, his bombers would attack Tokyo at night from altitudes around 7,000 feet, carrying maximum loads of incendiary weapons designed to start fires in the city's densely packed wooden districts. LeMay's decision was controversial within the Army Air Forces. Lower altitude exposed bombers to heavier anti-aircraft fire and eliminated the defensive advantage of extreme altitude. But LeMay calculated correctly that Japanese night defenses were weak, that lower altitude would reduce strain on temperamental engines and turbochargers, and most critically, that operating at 7,000 feet instead of 30,000 feet allowed each B-29 to carry 3 times its normal bomb load. 334 B-29 seconds departed Mariana bases on the evening of March 9th, They carried no bombs designed for precision strikes against factories or transportation nodes. Their payload consisted entirely of M69 incendiary cluster bombs, each containing 47 individual bomblets filled with napalm gel. These weapons were specifically designed to start fires in urban areas, to overwhelm firefighting capacity through sheer numbers of simultaneous blazes, and to create firestorms that would generate their own winds and temperatures. The results exceeded even LeMay's expectations and horrified those who witnessed the destruction. In 3 hours, American bombers dropped nearly 2,000 tons of incendiaries across Tokyo's most densely populated districts. Individual fires merged into vast conflagrations. Thermal updrafts became self-sustaining winds that sucked oxygen from shelters and generated surface temperatures exceeding 1,800 degrees Fahrenheit. An estimated 100,000 people died that night, more than either atomic bombing would later kill. 16 square miles of the city burned completely, leaving only ash and twisted metal. More than 1 million people lost their homes. The fire was visible from B-29's 150 miles away, a vast orange glow that turned night into unnatural day. For Japanese defenders, the Tokyo firebombing demonstrated that even without exploiting high-altitude capability, B-29's could devastate their cities. Only 14 bombers were lost, despite flying at altitudes where every anti-aircraft gun could reach them. Japanese night fighters, lacking effective radar and hampered by poor visibility, achieved minimal success. Most interception attempts failed to locate the bomber stream in darkness. The firebombing campaign that followed systematically destroyed Japan's urban industrial centers. Osaka burned on March 13th, Kobe followed on March 16th. Nagoya suffered massive raids on March 19th. City after city experienced the same pattern. Pathfinder aircraft dropped initial incendiaries to mark target areas. Following waves saturated those zones with thousands of additional fire. Bombs and firestorms developed that overwhelmed all firefighting capacity. Japanese civil defense organizations, already strained by earlier raids, collapsed completely under this onslaught. Fire departments lacked equipment and water pressure to combat simultaneous blazes across entire neighborhoods. Air raid shelters, designed to protect against blast and fragmentation, became death traps as firestorms consumed oxygen and raised temperatures to lethal levels. Evacuation procedures broke down as entire populations fled burning cities simultaneously, clogging roads and making organized civil defense impossible. What made this campaign particularly devastating was its sustainability. American logistics allowed continuous operations at this intensity. The Mariana bases, supplied by regular cargo ship convoys from Pearl Harbor and the West Coast, maintained steady flows of incendiary bombs, aviation fuel, spare parts, and all other materials required for sustained operations. Japanese intelligence officers tracking American supply shipments calculated that more tonnage arrived at Mariana ports each week than Japan's entire merchant fleet could transport in a month. This logistical abundance manifested in operational tempo Japanese forces could not match. B-29 crews flew missions every few days, sometimes daily during intensive campaign periods. Between missions, ground crews performed comprehensive maintenance on aircraft, replacing worn components, upgrading systems, and ensuring every bomber launching was mechanically sound. Japanese fighter units, by contrast, suffered chronic shortages of spare parts, fuel, and ammunition. Operational readiness rates declined steadily throughout early 1945 as maintenance backlogs grew and supply systems deteriorated. The human cost was equally asymmetric. American aircrew casualties, while significant, remained sustainable given the training pipeline producing replacement crews. Japanese pilot losses were catastrophic and irreplaceable. By April 1945, the average Japanese fighter pilot defending the home islands had fewer than 50 hours total flight time. Many had never fired their guns in training due to ammunition shortages. They faced American crews with hundreds of hours of flight time, extensive gunnery training, and combat experience. These poorly trained Japanese pilots flew obsolescent aircraft against the most sophisticated bomber ever deployed. The outcome was predictable. On April 7, 1945, during a major raid on Tokyo by more than 100 B-29 seconds, Japanese fighters attacked the formations with desperate courage and achieved almost nothing. American records show 2 bombers damaged enough to require emergency landings at Iwo Jima. Japanese losses exceeded 30 fighters, destroyed with minimal damage inflicted. Back at the Nakajima testing facility, where engineer Shindo had first examined the recovered cannon turret in March, technical teams worked frantically to understand American fire control systems. They had now accumulated components from multiple crashed B-29 seconds. The wreckage told a consistent story of technological sophistication Japan could not replicate. The computing gun sights incorporated miniaturized gyroscopes that measured aircraft motion in 3 axes. These gyroscopes, manufactured to tolerances measured in thousandths of an inch, maintained stable reference platforms for calculating lead angles. Japanese factories lacked precision machining equipment to produce comparable gyroscopes. Even if designs were copied exactly, Japanese manufacturing methods could not achieve required tolerances. The remote control turret mechanisms used electrical servo motors, driving hydraulic actuators to position guns precisely according to commands from computing sites. These systems responded in fractions of a second, tracking targets smoothly while compensating for aircraft vibration and motion. Japanese engineers had developed similar systems experimentally, but never achieved reliability required for operational deployment. Most impressive were the electrical interconnections coordinating the entire defensive system. Each B-29 contained miles of wiring connecting turret control stations, computing sites, power distribution systems, and intercom circuits. This wiring was manufactured to exacting specifications, with proper shielding to prevent electrical interference, secure connectors that maintained contact under vibration and temperature extremes, and redundant paths ensuring system functionality even with damage. Lieutenant Niwa, compiling his final technical assessment in April 1945, concluded that replicating B-29 defensive systems would require wholesale transformation of Japanese electronics and precision manufacturing industries. Even if such transformation were possible, which he doubted, it would take years to implement. Japan did not have years. Japan barely had months. The strategic bombing campaign's cumulative effect on Japanese war production became undeniable by spring 1945. Aircraft factories burned, machine tool plants were destroyed, transportation networks collapsed under repeated attacks on rail yards and marshalling facilities. Raw materials, even where available, could not reach factories that still functioned. Workers abandoned industrial areas to flee burning cities or dispersed into rural regions where they could find food. Japanese aircraft production, which had peaked at approximately 2,800 aircraft monthly in September 1944, declined precipitously throughout early 1945. By April, output had fallen below 1,000 aircraft monthly. By June, fewer than 700 aircraft were completed. Quality deteriorated as experienced workers were drafted into military service and replaced by untrained conscripts. Many aircraft rolled off assembly lines with defects that made them dangerous to fly. The Nakajima Homare engine, Japan's most powerful radial engine design, and the power plant for the Ki-84 Hayate fighter, exemplified these quality problems. In theory, the Homare delivered impressive performance, 1,800 horsepower, sufficient to propel fighters to speeds exceeding 400 miles per hour at altitude. In practice, most Homare engines suffered from overheating, oil leaks, and premature failure. Poor quality metals, inadequate heat treatment, and lack of proper machining created engines that frequently failed after fewer than 50 operational hours. American engines, by contrast, demonstrated reliability that Japanese engineers found almost incomprehensible. The Wright R-3350 engines powering B-29 seconds, each producing 2,200 horsepower, routinely operated for hundreds of hours between overhauls. When engines did require maintenance, abundant spare parts and well-trained mechanics ensured rapid turnaround. The contrast revealed not just technological gaps, but fundamental differences in industrial capability and organizational competence. Japanese attempts to develop countermeasures to B-29 defensive firepower produced several desperate solutions, none effective. The Army Air Force's Technical Research Institute experimented with upward-firing cannon, called Schräge Musik, by German advisors who had shared this technology. Fighters would approach bombers from below, where defensive coverage was weakest, and fire upward into unprotected bellies. This tactic showed promise in testing but failed operationally. Installing upward-firing cannon required removing standard forward-firing weapons to maintain weight limits. Pilots approaching from below had no way to aim except through crude sighting devices, making accurate shooting nearly impossible. The few successful attacks using this method required ideal conditions and exceptional pilot skill, neither commonly available in 1945. Armor protection for fighters was increased on some models, with additional plates protecting pilots and critical systems. The added weight degraded performance to levels where heavily armored fighters could barely catch B-29 seconds at altitude. Pilots reported that armored fighters climbed so slowly that by the time they reached bombing altitude, the B-29 formations had already released weapons and were departing. The most radical proposal involved using rocket-powered interceptors to achieve rapid climb rates and extreme altitude capability. The Mitsubishi J-8M Shusui, based on the German Me-163 Comet, promised performance that would theoretically allow interception of even high-flying B-29 seconds. The aircraft's rocket engine delivered phenomenal thrust, propelling the tiny interceptor to speeds exceeding 600 miles per hour and altitudes above 40,000 feet. Only 7 J-8M prototypes were completed before war's end. The single test flight that occurred ended in disaster when the engine failed during climb, causing the aircraft to crash and killing the pilot. Even had the J-8M functioned perfectly, operational limitations rendered it impractical. The volatile rocket fuel, a mixture of hydrazine hydrate and methyl alcohol, was dangerous to handle and in short supply. Endurance was measured in minutes, barely sufficient for a single attack pass before fuel exhaustion forced landing. Training pilots to fly such an unusual aircraft would have taken months Japan did not possess. By summer 1945, the strategic situation had deteriorated beyond recovery. American naval forces blockaded Japan completely, sinking any vessel attempting to bring supplies from the Asian mainland. Submarines prowled coastal waters, destroying fishing boats and small cargo ships bringing food to starving cities. Surface warships bombarded coastal industrial facilities with impunity, knowing Japanese naval power had effectively ceased to exist. The atomic bombings of Hiroshima on August 6th and Nagasaki on August 9th added horrific punctuation to Japan's defeat, but the conventional bombing campaign had already destroyed the nation's ability to wage war. Those atomic weapons were delivered by B-29 seconds, aircraft whose defensive capabilities had proven insurmountable to Japanese interceptors throughout the campaign. The Enola Gay, carrying the Hiroshima bomb, encountered no opposition during its flight to target. Japanese radar detected the small formation, but defenders had learned that attacking a few B-29 seconds was as futile as attacking hundreds. In the aftermath of surrender, occupation forces catalogued the extent of destruction across Japan. 64 major cities had suffered significant firebombing damage. Total urban area destroyed exceeded 170 square miles. Approximately 300,000 civilians died in conventional bombing raids, with another 300,000 injured. Industrial production had collapsed to perhaps 10% of 1944 levels. Transportation infrastructure was shattered. Agricultural production had fallen precipitously due to labor shortages, fertilizer unavailability, and direct bomb damage to farming communities. Japanese aviation industry representatives who met with American technical teams during the occupation expressed bitter admiration for B-29 engineering. Colonel Yasuda, whose early assessments had dismissed 20mm cannon armament as improbable, examined intact B-29 seconds at Japanese airfields now occupied by American forces. Walking through the aircraft, observing the remote-controlled turrets, examining the central fire control system, touching the massive 20mm cannon in the tail position, he understood with painful clarity how completely Japan had been outmatched. In interrogation sessions, Japanese officers provided frank assessments of why their defenses had failed so catastrophically. The answers consistently emphasized not lack of courage or effort, but overwhelming technological and industrial disadvantages that no amount of fighting spirit could overcome. Japanese pilots had pressed attacks with suicidal determination. Japanese engineers had worked desperately to develop effective countermeasures. Japanese factory workers had labored around the clock to produce sufficient aircraft and ammunition. None of it mattered. American industrial capacity produced B-29 seconds faster than Japan could shoot them down. American technology created defensive systems Japan could not penetrate. American logistics sustained operations at intensity Japan could not match. The defensive armament that Japanese planners had initially dismissed as impossible propaganda turned out to be entirely real and utterly devastating. Major Makoto Ogawa, who survived the war as one of Japan's few successful B-29 killers with 7 confirmed victories, later reflected that his success came only because circumstances had been extraordinary on each occasion. Surprise attacks from ideal angles, mechanical failures that separated individual bombers from formations, weather conditions that obscured bomber formations until he was too close for defensive gunners to react effectively. Against formations of undamaged B-29 seconds, alerted and flying proper mutual support, even the best Japanese pilots rarely succeeded. The broader lesson Japanese military leaders absorbed from the B-29 campaign related to industrial warfare's fundamental nature. Modern combat was decided not primarily by individual courage or tactical brilliance, but by industrial capacity to produce superior weapons in overwhelming quantities. A nation that could manufacture thousands of B-29 seconds, each one a flying fortress bristling with remote-controlled 20mm cannon and sophisticated fire control systems, and possessed military power that technological inferior opponents could not effectively resist. Engineer Shindo, kneeling beside that recovered cannon turret back in March, had grasped this truth immediately. The turret represented far more than a single weapons system. It symbolized an entire industrial and technological ecosystem capable of designing, producing, and supporting complex military equipment at scales Japan could barely imagine. Every component, every servomotor, every foot of specialized wiring, every miniaturized gyroscope in the computing site, and spoke to manufacturing capabilities and quality control standards that exceeded Japanese achievements by margins too large to overcome quickly. Japanese industry in the post-war years would eventually develop those capabilities. Companies like Nakajima and Mitsubishi would transform into manufacturing powerhouses, producing vehicles, machinery, and electronics that competed globally. Former aviation engineers would apply lessons learned from examining American equipment to civilian products. The precision manufacturing techniques that made B-29 defensive systems possible would eventually become hallmarks of Japanese industrial production. But in 1945, those capabilities lay decades in the future. In 1945, Japanese engineers could only examine American equipment with the sick understanding that they were studying technology their nation could not replicate, deployed in quantities their factories could never match, supported by industrial and logistical systems their country had never developed. The story of Japanese forces confronting B-29 defensive armament ultimately demonstrates how technological sophistication, combined with industrial capacity, determines modern warfare outcomes. The 20mm cannon that Japanese planners had dismissed as impossible turned out to be entirely possible when supported by advanced metallurgy, precision manufacturing, sophisticated electronics, and systematic quality control. Those defensive weapons, fired by American crews in aircraft operating at altitudes Japanese fighters barely reached, carrying bomb loads that dwarfed anything Japan's Air Force could deliver, represented a form of military power that transcended traditional measures of courage or skill. When B-29 seconds appeared over Japanese cities, their turrets traversing to track attacking fighters, their 20mm cannon firing, explosive shells with mechanical precision, they carried proof that wars were won not just on battlefields, but in factories, research laboratories, and engineering departments. The Japanese High Command had gambled that American willingness to fight could be broken through initial victories and a defensive perimeter too costly to breach. They had fundamentally miscalculated American industrial might and national resolve. By the time Japanese officers examined recovered B-29 components and realized the true scale of American technological superiority, defeat was already inevitable. The defensive systems they had dismissed as propaganda were utterly real, produced in overwhelming numbers and representative of industrial capabilities Japan could not match. 5,000 B-29 seconds would eventually be built before production ended in 1946. Those aircraft would burn 64 Japanese cities, destroy the nation's industrial capacity, and demonstrate beyond any doubt that modern warfare's decisive factor was not individual valor, but collective industrial and technological power. The 20mm cannon Japanese engineers initially thought impossible became symbols of a larger impossibility. The notion that Japan could win a sustained industrial war against America's mobilized economic might. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.